Ah, I missed my cue. Wait, where's the chat? Oh my god. There it is. Hey there. It's been a while. You've been stream absent for like 4 or 5 weeks. I don't actually know. But we're back. Yeah, the auto ducking still works when even the channel's turned off. Kind of annoying, but okay, might need this later. Good evening, ladies and gentlemen, says Johnny Bergdahl. Well, hello there. It's been a while. It feels like it's been a while. I took longer to prepare than I thought I would. Oh, what? Okay. I'm too centered, aren't I? No, the other way. You can see my janky LED strip. Feeling all better? I'd say I'm 85 to 90% there. If I am really active, I still feel it sometimes, but other than that, I think it's going pretty okay. Turn the music down just a little on the silent moments. Yeah, I still need to adjust it from the intro. There. That should be better. Let's listen to it. Yeah, that's okay. It's a little bit low. There. Good. Welcome back. We missed you, says Rob Starkey. I missed you guys too. I like doing these live streams and blowing stuff up and, you know, what else are we going to do on a Friday evening? Now it's very silent. I already turned it up a little bit. And it's a silent song, so hey. Let's see who's here. Johnny Bergdahl, already named him. Ira Tarto, still don't know how to pronounce his name. Earth Gamer XE is back. Snail Boy. Jaco Weiss. Wes, I guess. M6 Droid. Oh, it's a lot of familiar faces. That's nice to see. Gijs Ende. Hello. So, we're going to wait until 15 over, as traditional. And we currently have the Coke Zero and... Let me show you. I think I also need to enable chat here. Where's the chat? There's no chat. Chat. There's the chat. Oh, and I need to fix this guy, I guess. What was it again? Shift? No, it's definitely not Shift. Control. It's not Control. Is it Alt? It's Alt. There we go. Because we're going to need that guy later. Let's put it up here. There we go. Nice. So, we got Fanta Lemon and Coke Zero Sugar Cherry. I think it's going to be Fanta Lemon. I'm feeling lemony. I think I will do drunk gaming on Twitch. What? I know you're going to do drunk gaming on Twitch. Okay. Does that pull a lot of viewers? I don't drink alcohol, so that's not something I can do. Sugar cherry. No. This is zero. No, no sugar for me. Yeah, so if what happened earlier this week happens again during this stream, we are guaranteed magic smoke. But then it's not guaranteed because I don't know if it'll happen again. Because I've been doing a little bit of pre-testing. Q just gets drunk with life. Isn't that right? Well, is there a better drunk than getting drunk with life? I don't know. Oh, I didn't clean my shirt with the cat hairs and stuff. Oh no. I know this is a favorite question from a different Dutch YouTube streamer, and I don't have all the fancy animations, but are you a cat or a dog person? I'm a cat person. I don't dislike dogs. Dogs are nice, but they take a lot of care, and we have 3 cats now. We had 2, but then one kind of just like started living here. And, you know, I like cats. They're very stubborn like me. Doggo, okay, yeah. I don't have anything against doggos. I get it. It's just, I don't think I could make the time investment and getting up on time and things like that. Dog person forced to live with a cat. But do you at least also have a dog, Philip? Yeah, that's Frank, that's who I meant, Dutch Taurus. 2 cats. Cat for sure. Cats are assholes, but that's partially why I like them. So, dog, cats feel like they're always judging you. Yeah, that's true. That's true. Ah, poor Philip. Well, maybe if you get to work from home more often now with the new job, maybe you could get a dog again. I don't know. Cats for sure here. We didn't lose the signal. What are you talking about? Only 40 people, that's what I get for not streaming for like 5 weeks. It's like YouTube's like, big to you, and, you know, find your own followers. If you can pet a dog, for sure it's like a child. They are very social, and that's what I like about it. But I do like cats. But they're not social. No, well, you know, I have a rapport with our cats. They certainly know who I am and what the rules are. Doesn't mean they always follow them, but generally they know what's up. Dogs for sure. Yeah, okay. Oh, you're going to renovate soon. Yeah, that would be poor. No, sad for the little guy. With a cat, no, you're enslaved to their whims. If you give them that room, yes. But it doesn't have to be that way. But okay. Introduce yourself. Who are you again? I am Quindor, Lord of all LEDs. And I don't know. 40 people who didn't slap the like button. Are you saying nobody slapped the like button? What? Oh, maybe I'm a bit too close to the microphone. Sorry. You owe us some smoke now. I'll try and oblige. I'll try and... I have two testing devices or subjects, and we'll pump the voltage on one of them. Okay. When does the Dig2Go page go live? It's still in construction, yes, but there's a lot of work that's been done there, as you can probably see. And currently on the plane to the US, there is the first big batch of Dig2Go, including bundles, and we'll be releasing those pretty soon. Draadstaal's bad at math. There we go. Now YouTube says I have 44 viewers and 23 likes. That's quite a good ratio for on YouTube, that's for sure. Cats love the food you give. Dogs love the one who gives the food. I don't know. I think cats are a bit more complex than that, but okay. Is there a difference in this Dig2Go production batch? Actually, there is. On the first 1,000 we did... So basically the first batch, I used some ceramic capacitors in certain places. And in some scenarios, when combined with a certain type of power supply and a certain type of LED strip, and you had to find the perfect match, there could be a slight squealing noise heard from the box because the PCB was encased. So I noticed that and I changed that for the true production batch, which is this one. And that issue is now gone. So there's no functionality difference. If you happen to hit that specific combination, I I guess you could notice it, but otherwise, basically, it's basically the same. You can order the Dig to Go already, sure. It's live on the international store, the worldwide store, and it'll be live soon again on the Dr. Z store, as will a lot of other stuff. So we sent the biggest shipment ever to Dr. Z's. So if you've been waiting a few days more, and you'll get it. Basically everything except Dig Octa. There's some Dig Octa, but not a lot. And that's because of the weight and the cost. What it costs to ship that by plane. And we're looking into sea freight shipment for that. So that might be a few months, but it's certainly available from worldwide. And we're trying to get that well available in the US also. Yeah, I switched to a different capacitor type for that part of the circuit, Rob. Draadstaal invented math when he was 8 and went to school uphill both ways on 1 foot? What? I don't know. Now is a good time to insert an ad. I do not agree. I'm just having fun with my folk here. Come on, YouTube. Will there be a Quinled site? Yes. At some point when I finish some projects I'm working on right now, like you know, these guys, the analog boards and such, I will start working on compiling a Quinled site with information on there, links and articles and things like that. Kind of like the Quinled site. It'll likely explode less than that did, but yeah. Go for the ad. I have premium. I don't actually know if I get more money if I hit the ad from premium members. I don't really care either. So, I'm not going to do ads. I'm here for you guys, not for the ads. I am from the Netherlands. Can you send one over from... Oh, PostNL. Like the Dig to Go so much. Actually, no. I don't have many here. I have like 5 of the latest version, and then I have some of the other versions because I, of course, test them. But there's no stock here. I mean, you can really see how full my room is. There's no room for stock. Not in this house. So, no, I don't keep local stock. We are working on improving EU for this year. It's one of the goals for this year. One of the goals is get sea shipment done and regular shipments to the US. So that has better stock and keeps up, and, you know. And the second is either arrange FIOS or IOS or whatever, so the tax thing isn't an issue anymore in Europe. And at the same time, we're working on getting a EU local store or something like that set up. But that might be a later goal in the year. But we are certainly aware of the issues in regards to shipping prices, and we are working on that. Oh, Draadstaal has a few lying idle there. Right, so today, you already saw it in the thumbnail, we have this guy. Oh, I'll show it over here. This is a AliExpress, the link is in the description, of course, car light, and it has a single big LED there, and a reflector, and it basically runs off of EU store employee sign up open. I don't think you want to work there, Philip. It's a minimum wage repackaging job. Still costs money, but you know. So these are no faces in the way. There. 4-inch white flood, 30 watts, 10 to 48 volts. And black wire is negative and red wire is positive. 10 to 48 volts? How? There's just an LED in there. Or is there? I don't know. I don't actually know what's in here. One of the things I want to do today is break this open somehow. I don't know how this is constructed, so it's going to be interesting. I believe this is plastic. So it's not metal. I think I'm a bit hot. There, let's turn that down a little bit. And, well, I already tested this one a little bit, and it's showing some interesting behavior. And since then, it's, yeah, I don't think you can hear that. something is rattling inside. Because this one released the magic smoke, but it still works. No clue. 40 HQ container Shenzhen to Rotterdam of, oh, okay, 40 HQ, oh, €1,000, yeah. Yeah, but then I need a place to store it, and then I need to import tax it, then I need someone to handle things, then when an order is placed, someone needs to pick that order, and then someone needs to ship it again. Because people are like, why can't you sell in the EU? It's cheaper. Well, maybe if you don't count all those things, but in the end, you're still paying tax, and there's a lot of other stuff you need to do to have it be delivered at your place in a correct fashion. So it's things to work out, but I remember what we've talked about there, Dutch maker, don't worry. Chief Convincing Officer. I sent him a mail, I never got anything back. Maybe I should send it again, I don't know. Yeah, rattling noises and Chinese glass plastic. So we'll hook this one up and see what happens, and then we'll work on the other one, which I haven't hooked up yet. So maybe that will release the magic smoke. I am putting on my glasses because... Oh, holy shit. Okay, hold on. Yeah, you can put it in a warehouse, that's not a problem, but in the end, the customer is always paying the tax. It's just the $25 extra they have to pay for the tax declaration, that's the issue. Right, so let me show you the overview here. So we've got our little light, and we've got our power supply. This is not sitting right. Okay, we've got our power supply here, we'll turn it on in a minute. We have a AN Mini, which is 12 volt to about 60 volt incompatible, and it'll auto range that. So we're going to use our Raiden 6024 we built in a different live stream, and let's hook up the power. Right, and I already prepared this one because I was playing around with it. So this light already has some connectors. On the AN Mini, we have 2 positive outputs and then 5 channels of negative outputs, 2 high power channels and 3 normal power channels. Doesn't really matter much in this case, but you know. So right now it's plugged into channel 4. That's fine. So let me show you both in the picture. Let me turn this on. Sure, Squadra Munter, there's lots of ways to go about it, but like people are like, can't you sell it on AliExpress or Amazon? I can, but then we're talking a 30 to 50% premium just because of doing that. Maybe if you have giant amount of volume, that's not the case, but otherwise everything you do costs extra money. So if people are complaining about paying 10 euros extra getting it from China, but then the price goes up by 15 euros base fee, does it make sense to do that? Not in my opinion. So yeah. So that's why we're trying to find a solution that doesn't cause that, or not to that extent, and does have the added luxury of having it local, and yeah. So, we have our little power supply here. Let me try and... Nope. Okay. There we go. It's currently set to 36. Let's set that to 12 volt. And I have it limited to 3 amps, but that should be fine. Partner with Coca-Cola. They ship worldwide. Yes, I'd like to. Okay. So we have our light, we just have a positive and negative, it goes to positive and, well, negative. And let me open up my testing instance for Home Assistant, because my desk is a giant mess. There we go, I think, no, it's not that one. There we go. Okay, so let's boot up the power supply. Oh, it's already connected. It'll probably be fine. You can see the power supply, you can see the unit. I'll move the mouse over here. Do we have a fire extinguisher? We have some fire stop. So if a problem happens, we have fire stop. I like the name. It's a good name. It's a strong name. Okay, let's give it 12 volt. Beam. Okay, we have a little LED, and this is, by the way, the AN Mini we rebotched on the stream, because you can see all the flux still. Still working. So let's wait for the controller to boot. I can't see chat now. That's annoying. I'll put this here. There. Oh, Johnny Bergdahl with 50 SEKs. Thanks, man. Didn't that expire? What expired? I did not test if red is actually the positive, but it said so on the box, and I've already played with it, so... Yeah. Oh, didn't this expire? Wait, does the can expire? I don't know. It might have. It might have. Why is my audio so hot? Okay. So let me show you. I hope that's production date and not good until date, because then it might have expired a little bit. 05/2016. It's still liquid. It'll extinguish something. It got one job, yeah. Okay, meanwhile, the controller is booted. So I'm going to set it to 25%, and let's see what happens. Oh. The fire stop is now morphed into fire starter. I don't think so. I think mine are like 10 years expired. I still have 3 more years to go there then. No problem. So this is 25%. It's drawing 0.1 watt. That's not a lot. Wait, how much did it draw when it was off? Oh, it also draws 0.11 watt when it's off. What? This controller does not use a lot of energy. Okay, so let's go back to 25%. Oh, it does fade. Okay, let's go to, I don't know, 50%. There we go. Oh, that's already printed plenty bright. Okay. That's, yeah. Okay, let's go to, I don't know, 70%. Okay. Now it's actually starting to draw some power. Let's go to 90%. Oh yeah, you can see that it's, you know, starting to light me up. Okay, let's go to 100%. Okay, now we're at 21 watts. It actually peaked higher, that's interesting. 1.7 amps. And, well, it's certainly bright. Don't shine in my face, please. There. Interesting. So at 12 volt, we're doing 1.76 amps at 21 watts. Okay, that's good, I guess. Let's go back to 50. Okay, it doesn't really scale that linearly. I mean, this is not 50% brightness, and certainly not 50% power. This is like 1/100% power. I don't know. But still, I mean, let's set it to 85. It does, you know, curve nicely. Let's set it to 95. I mean, if you look here, you can still granularly set it to what you need. So let's set it to 92, for instance. Right? So it's a small band, but it's doable. I know, but this light is weird, Johnny. Actually, I might need to change something. I'm just thinking. I don't know what PWM frequency we're running this at. So let me go into ESP Home. Because that might also have something to do with it. Okay, channel 4 is running at 19,531 hertz, so basically 20 kilohertz. Let's take it down a notch and let's make it 1,000 hertz and see if the scaling changes. It's interesting, right? I think it's interesting. Flash wirelessly. Yeah, so we're going to break this open later on, because this one already released the magic smoke. It's still working, but it popped really loud. It filled up with smoke, and then it just kept working. So it's recompiling. Just 1 second, please. Yeah, well, we still have a second one, so let's see if that one does that too. It absorbed the smoke and put it back where it needs to go. I have a hard time believing it works like that. Oh well, we can see the power draw while it's booting and flashing and stuff. That's interesting. Cool. Okay, so it booted. Let's turn it on again to 25%. Nothing happens. What? Hello? Okay. 50%? Oh wow. That's not 1,000 hertz. What's going on? 75%? Okay, now it's stabilized. Let's go to 95%. So 95, 75. Seems the power scaling is now a lot more linear. 50. 69. Oh, it's starting to flicker. Oh, you can clearly see that over here on my. I mean, hello. This is the Quinled Disco Show. Why is it doing that? There has to be some kind of DC driver in there. So 25%. Oh, now it's off. What? 33? No. 40? Yep. What the? I don't know. But we're still at 12 volt. So interestingly, so at 20 kilohertz, we were able to perfectly dim in, no flicker it, etc. But we only had a small range at the top. And now at 1 kilohertz, we have a better range, but it's showing weird behavior, right? I do have a flicker tester, but I don't know where it is right now. But this is visibly like 20 hertz or something like that. But what we'll do is we'll say VSET. No, we don't want 12 volt, we want 24 volt. My controller can do that on the fly, that's fine. Am I hearing it now? So, I'm wearing headphones. Maybe a little bit. Okay, we're still at 40%. Let's go to 20%. Oh, no, didn't like that. 30%. It's back, but it's still weirdly flickering. 40%? Yeah, it's some kind of DC CC module, I think, also. But, you know, it's fun testing it, and we'll break it open later. So this is 40%, and we're already at 2 watt at 24 volt. Let's go to 60%. Okay. 75. Okay. 90. 100. So with the higher voltage, the lower PWM doesn't seem to be that much of an issue. Interesting. Okay, let's go back to 50%. I mean, it does work okay, just that, you know, the bottom part shows weird PWM, but otherwise it's fine. Right? Yeah. 12 gigahertz PWM. No, we can try that later. That's okay. Let's go right for broke. Oh, okay, that's not stable. Let's go to 48. While it's running, let's just double the voltage again. Okay. Didn't explode. Well, it already did once before, so... Okay. So, while we were at 54%, we doubled the voltage and the output actually dimmed. Okay. Let's go to 30%. And now 30% is perfectly stable. It's not flickering. 20%? Ah, okay, there's our PW. Wow. Interesting effect on camera, though. So, we're now at 48 volt. Let's go to 75%. Let's go to 100. Scaling kind of works. 80. 62. 45. So, in regards to usability, if you'd, for instance, want to have these guys in your garden to light up your trees or things like that, you could run them with one of the new analog boards at 48 volt, and you'd still have dimming control. Yeah, likely, I get that, Johnny, but just playing around with that. But you could string up, like, a few of them on a single channel, and then have a few channels if you want to have them individually controllable. But because they can run at 48 volt, and you can still control them, that's a very interesting system you can have there. Because then you can have very long, thin cables with no problem. And I mean, the dimming works fine. Yeah. Unless you go too low, let's go to 19%. But then we just have to up the PWM frequency a little bit probably, and we'll overcome that. Interesting. Do we want to up the PWM frequency again? While it's set to 48 volt? What do we want to make it? Do we want to go for 100,000 hertz? I think there's an ESP32C3 on here. I believe that can do that. 100,000 hertz. Let's do it. Save, install, wirelessly. In ESP Home, there's a way to set the frequency dynamically. What do you mean there, Event CJ? What's the max PWM possible? I think somewhere like 500 kilohertz. But the higher you go in kilohertz, the less granular steps you get in range. So there's a compromise there. Do whatever makes it smoke. I think we'll have to wait for the second one for that. I just wanted to show you this one first. Okay, we're back. Let's go to 30%. Okay, that seems fully stable. Let's go to 20%. Oh, now we can go lower. 20%. Oh, and we're drawing 0 amps at 0 watts. Okay, let's go to 10%. Oh, okay, 10% is too low. Let's see when it reacts. 10%, let's go to 11%. Oh, I'm watching on the screen. Let's go to 12%. Oh, come on. 12. Free energy! Exactly! Okay, let's go to 15%. There. Ah, now I can show you what the LED actually looked like. No, I can't. Oh, probably I can. So, the LED is actually made of several sub-LEDs. There, can you see the... Oh wait, I need to... Can you see the subframe there? So it's basically... It's a single LED package with a single dome, but it has 9 individual diodes, I think, inside of there. Can you see that? And one of them is slightly dimmer, or 2 of them actually are. I'm wondering if those are which blew up. But we'll see if the other one blows up too. So we're at 15%. Let me try and normalize my camera again. I think that's okay. Right. There's 7 to go to smoke. 3 by 3, yeah, exactly, Dutch maker. Oh, what? Oh, sorry. Now this is it's showing different behavior now. If I go from 71% to 30%, it dims down, it flickers, and then let's go slower. 30 to 40%. 40 to 50%. Okay. 50 to 60%. It's not really linear transitioning anymore. 60 to 70%. Oh, see that? So let's go from 70 to 60% again, back. It's probably the circuit that's in there, and it's likely a DC constant current driver, having to flip around how it uses whatever is coming in. No, these are just a single color white, and not even a great white at that. But yeah, at 48 volts it again behaves differently, because at certain thresholds it'll dim down and then dim up again. But I'd say it's still usable, because we can still... Oh wow, it's now using 30 watts. What? Well, it's bright. That's not a problem. So it does need the highest voltage. What? Okay. We're now at 100%, right? And it's using 21 watts. Now I'm going to 90%. What? 85? Okay. So at 100% it uses 22 watt, and at 85% it uses 32 watt? Exactly, Dutch Taurus. 1 watt for the light output, 29 watt for heating up the magic smoke generator. Hey, the real life hater is here. Welcome. So yeah, that's interesting. Is it heating up? I guess a little bit. Anyway, let's go back to 24 volt and let's do that while it's running, like we don't care. There. And now it's behaving a lot more linear again. Interesting. Wow, now we can dim it down really low now. Okay, let's go to 12 volt. It's barely on. It could stay on. It is not. I mean, it's a 20 to 30 watt light. So with like 100 lumen per watt, that's like, well, let's say 2,000 lumen at least. So that's pretty bright. Take it apart. Yeah, we'll do that after we test the second one. So let me reflash this thing because I'm going back to my 20 kilohertz ish. Install wirelessly, and then we'll hook up the second one. You wrote it in DC chat, but how to add multiple effects over one another without flickering? Not sure what you mean there, real life hater. Okay, we're at 12 volt and we're back at 12. Let's turn this off. At 20 kilohertz. Now let's unpack the other one and see if we can, you know, what it does. So this is a slightly different variant. By the way, it comes with all the tools to mount it to your truck or your car and a brace or a bracket. And the construction, you see, even the foil is still on there. Oh, wait. Sorry. Wait. Shut down the music. Okay. Oh, nice. These would be water resistant, I'd say. I mean, they're meant for mounting on a truck. So, I mean, and the construction wise, this is one. The luminous flux? Oh, probably. But, I mean, it's just a single shell with then a top cover. And I think later, when we're trying to open it, we'll have to pry this top cover off to get to the insides, but we'll have to see. Okay, let me wire this up. Yeah, you can have them in different colors and different reflectors and all kinds of different variants. I went for the simpler variants. Let me check how I want to wire this up. Well, it's likely constant current internally, but we'll see. Okay. like that, I think. Let's turn the power supply on again at 12 volt. Okay. I don't know about multiplexing different effects on top of each other there, Real Life Hater. I've never done that before myself, at least. Okay. Oh, it's already on, but at 28%. Let's go to 50%. There we go. Ah. Now I have a orange spotlight, because not only is the color different, although I suspect the color of the LED is the same, it's just the cover that's different. This one has a perfectly smooth reflector instead of the diffused reflector of the other one, as you can see here. So it also throws off a different light pattern. Stop cheating and release the magic smoke! Thanks, Philip, for the €5. So, I now have a giant spotlight here, as you can see there on the wall. Well, the other one was very diffused. This one is very spotlighty. Okay. Let's go to 100%. Let's go! Okay, well, it behaves the same as the other one. It's definitely bright. I mean... You're only here for 10 more minutes. Oh no. Well, maybe we'll get it blown up in that time. Let's see. Let's go back to like 36%. Yeah, this dims linearly again. Let's go to 20%. So it seems my initial settings with about 20 kilohertz and 12 volt makes it very well behaved. 10%. Yeah. Same arrangement of LED. 3x3, so 9. Just push it to 60 volts. We'll do so in a minute. Well, we have to do our steps here. So let's set it to 50%. It dims very nicely. And while it's doing that, let's go to 24 volt. Oh. It's suddenly a lot more bright. A lot brighter, I should say. Okay, let's go to 20%. 10%? Okay, you can still dim it down real low. Let's go to 75%. You see that weird behavior? Let's go to 100%. So it actually lowers the current if I go to 100%. And if I go to 75%, 50 or 60%, I don't know. It goes up. It outputs less light, but it does go up. It doesn't change that much, I guess. Still, it's usable. If you wanted to use this, that'd be fine. You can just, take it into account, have some presets, and then those presets will do fine. Okay, let's set it to 50%. There. And let's go to 48 volts. Are we ready? Nothing happened. I believe... Oh, no, wait. Last time I went to 36 volts. There. What the... Did you see that? I'm trying to recreate... Oh, my God. If I hit it at... Oh, there we go. It blew. Can you see the smoke? Turning it up? Yeah, well, no, that's not working. It hit 50 watt and something blew. but it's contained in the light. It spiked for a very brief moment around 34%. But the weird thing is, it's still working. I can still dim it. I mean, this is 100% now. Still the same wattage. This is 74%. 50%. But the weird voltage spiking is... the weird wattage spiking is gone. Right before, if I had it, it blew. So it's still at 36 volts, and we have it at 35%, but it's now only drawing 1.43 watts. And if I raise it to 58%, I don't know, it's now drawing 1920 watts. Magic Smoke fixed it. Exactly, Magic Smoke removed the voltage spiking. But it's only running at 36 volts. It's not even running at 48 volts there, Johnny. Yes, yes, this light needs a good smoke treatment before you can use it. AI LEDs. Okay. Now, I need your help. How do we open this? Do you guys agree with me that this is likely a cap that we can pry off? Because I don't see any screws here on the side or on the back or anywhere. You can't open this? You've never met me, have you? Hammer? Well, hammer, Sleiptal, those are last resort options, come on. Use Big Clive's X-Ray Deluxe. Probably glues as it's waterproof. Yeah, that's true. But let's, I already have my safety glasses on, kids. Let's try and pry this up, I guess. I don't know. Oh, poor screwdriver. How the hell does this come out? And then is it glued in as a module? Hot air gun and melt it off. Run your car over it. I think it actually would survive because it's fully metal cast. Maybe I should just stab it and then peel it off that way? Is that an idea? I don't have a vise. And I doubt I could... Yeah, I can't really squish this mold. Isopropyl? I don't know. Let's see if there's glue here, I guess. I don't know. Bandsaw? I don't know. I'm thinking maybe I just shatter it. Well, this is, I think, for a decoration. You can't twist it. It is not... How would I hot plate this, Emil? This, you can't... You need a flat surface for a hot plate. And I can't put this on a hot plate. It would just melt. Heat gun and suction cup. Eh. Safety glasses are no longer an option anymore. Yeah. I was hoping I could pry this out somehow, but it's really stuck in there. So I'm thinking maybe shattering it from the middle, and then I can pry the pieces off, because the glue is on the edges. And then there's likely screw holes underneath here. Yeah, but you can't heat something with a heat plate that's not touching it. Sorry about that. Maybe I should get a thicker screwdriver. There we go. Now we can put some force on there. Oh, something's happening. Am I bending my screwdriver? Not yet. There we go. Oh, oh. Yes! Raw power! I heard it pop. Okay, I'm just gonna try and bend. Oh. Oh, I broke some other stuff off. Wait, what? Where did these come from? Chat ideas don't convince Quinder. Nope. Oh, there's a little hole here now. Okay. Interesting. No, I think I can brute force it out of there. Let's see. Good night, Johnny. Have fun at the bars. While I'm prying open lights here. We're getting there. Oh, I hear it unpopping, so we're close. Oh, I saw it. I saw it was open. Ow, ow, ow. Do we have a chief safety officer, Philip, here? Can we ask him if this is allowed and safe? There we go. And... Okay, let's do it this way. I don't know if this is going to work. Well, here's the glue. That's obvious. CSO says stop now. We fired him last week. Oh no! Why? Oh, okay. Did he feel I was not practicing safe work ethics? Ethics? Ooh. Come on, stupid lid. Okay, I'm done with this lid. It's going... Okay, there. Okay. Okay, yeah, the smoke was still in there. It's not anymore. Okay. Wow, there's a lot more in here than I thought. So, let's see if we can get this reflector off. Probably also kind of glued down. There. One reflector. Okay. I'm not sure it's metal. No, it's plastic. Okay, well, that's okay. Well, there we have it. Including exploded guts. Let's see what exploded, right? I think that's exploded stuff. So looking here, we have the incoming wires. The minus and G plus. What's G plus? Okay. So there's something here. Maybe for when they're doing RGB or something like that. So this is the CCG 7070 6 volts 430, okay. this looks like a testing point, just like over here and over here. There could be a diode over here, but there isn't. There's a cap here, and I'm thinking that one blew its guts, because that cap doesn't really look healthy anymore. It's certainly bulged up, but I think it kind of lost its intestines on the bottom. CSO says lick it. No, the safety officer would never allow that. 2 resistors, 3 more resistors, ceramic cap, some kind of constant current driver probably. Let's see if we can get the. Oh, there's text on there. Hold on. Let's see here. Can you guys Google for me? It's the AP2400. Yeah, AP2400. And then D2150. The brown wet stuff is probably what's supposed to be in this exploded cap, but it's kind of tilted up on this side, and the brown goo got out. Okay, and then this is likely a MOSFET, and we have an inductor, so it's likely a P-channel MOSFET with an inductor, which is driving this LED as a constant current. And I don't know why this is. Oh, this is desiccant for dehumidification. Okay. Interesting 6 volt. Yeah. I would have expected 9 volt like you did. But I mean, it's a decent construction, and I don't know. Oh, we can unscrew the board. We can just unscrew the board. What are you doing? Why am I doing? Yeah. Oh, okay. Two different kinds of screws. That's interesting. Certainly screwed in there. Now, if it's a really good product, there will be some thermal paste on the bottom of this. And it's probably stuck down, but let's call this lost anyway. Not sure I'll be able to remove this. Is there another screw here? Let's get this gunk out of the way. Oh, sorry. Go away, gunk. Said AP2400. Once it's out, I'll try and have a better look. Well, this needs to go. Let me cut the wires. Okay. Is there a screw I'm missing? Now, what I said before is that a hole on the back opened up. And that's this one. My screwdriver fits in there. Right, that helps. Now we can lift up the PCB a little bit. But I'm wondering if there's a screw I'm not seeing, or that it's just something else. because it's lifted up now, as you can see. If the creator of the lamp will be watching the stream, he'd be like, man, they could have just asked. But if he is, could you upgrade this capacitor to 100 volt, please? Thank you. AP2400 plant growth lamp drive circuit high power down pressure constant flow IC. Chinesium translation. Thanks there, Scott. Yeah, so it's a constant current driver of some sort, which is logical with, you know, this type of LED arrangement. What is holding it down? I think it's just glue. Oh, there we go. There, it's up. Okay. So let's take a very close look at that guy for you guys. So let's see if we can get even closer. I don't think so. Oh, okay. No, no. Yeah, that's too hard to read. I'll read it myself. Oh, it's an... oh, you can't see that. It's an aluminium PCB. Nice. And there is some thermal goop there in the middle, as you can see also as a residue over here to sync it to the rest of the body. That's good. That's good construction. Oh. Yeah, so the capacitor says 50 volt and it popped at 36 input, but since it was PWMing, it likely created some kind of resonance or higher peak voltage. So, yeah. And if a product is rated for 48 volts, you shouldn't use a 50 volt capacitor. You should use 100, at least 75, but preferably a 100 volt capacitor, in my opinion. And, I mean, truth to word, can you guess what kind of capacitors are on my board? My board, which is 48 volt rated, has 100 volt capacitors. 100 volt, 100 volt. This one's 35 volt because it's in a 5 volt circuit, I believe. This is also, or in a 5 or 10 volt circuit. But and these are also 100 volt. So, bad design, or, well, better design. No, I would say with a 50 volt cap, that is not correctly rated for 48 volt in. Correct. So we have a P30 NF06. That is a MOSFET, and it's a P channel, probably because it starts with a P. That makes sense. Let me focus it like this. So basically what we have here, trying to focus it, hold on. It doesn't like it. Why aren't you focusing? No, okay, whatever. We have an input capacitor and an input diode. The diode's likely there to do reverse polarity protection. Input capacitor, 2 resistors, maybe to limit current, don't know. Then we have a smallish capacitor over here, which is likely tied to this constant current driver. The constant current driver does not have an internal MOSFET. It uses this external MOSFET for that. It has some resistors to set the sensing voltage and things like that. It has another diode here and a big inductor to basically make a true constant current. And that is then output to the LED array. And, well, as I mentioned, it's an aluminium PCB, so it's single-sided, so all the traces are just on top here. And it was neatly heat-sinked into the chassis and screwed down and glued. Construction-wise, this is good. I mean, this is a decent chunk of metal here, and running 30 watts through this, probably perfectly fine. Only thing I can mention on this circuit is this capacitor should have been 100 volt, not 50. That's it. It's 22 UF. That's fine, I guess. Could you test the LED directly? Check if the forward voltage is 6 volts. I guess so. I'm trying to see if there's maybe testing pads, but I don't think there are. One thing of note, seems there's a little bit of rust there. That's never good. If it's rust, I don't actually know. Could be flux, I guess. So I see the traces. If I hold it right, you can see the traces there. They're pretty thick, so I can probably scratch those. I don't have a grinding pen, but I can probably scratch these and then just apply positive and negative. But I'm a bit confused because the inductor seems tied to the negative. And the diode seems tied to the positive. That doesn't make sense to me, because we have a P-channel MOSFET. Yeah, I'm not sure what this is for, because it's not connected to the LEDs in regards to traces. Let me, sure, I mean, this is what this stream is about, just having fun with this thing. Let's see if we can focus again. There, finally, Jesus. Okay, let me try and grind this, I guess. What should I use to grind that? I guess just a screwdriver. That's one. That's two. It's just someone's left-handed. I think I was right about the cap, by the way, that these LEDs are always the same and this cap determines the color. Same as the diffuser. It's all modular components, so they don't have to make multiple versions. Okay, so we have exposed traces. I think I can use my multimeter probes to hit it directly. Hold on. No, not these. Yeah, 5 milliamp. That's a good start. I just don't know if my write-in is that specific. We'll have to see. I guess this doesn't work, huh? How do I get something I can probe with in there? I'm trying to think of a way to put it into the writing. I thought I could use multimeter probes, but Ah, no, because I have the 6024. And I believe that's less granular than... There's a P version, I believe, which has a digit extra. So I can only set it to... 100 milliamp. Right? Milliamp? I'm confused. You're right. That is 10 milliamp. Sorry. I am confused. I was just thinking about how to connect to these posts, because that's not easy. I'll just use the wires. That's okay. Lower voltage. Yes, don't worry. Well, engineers make mistakes. Okay, board out of the way. Let's see, VSET, let's start with 5 volt. Draadstaal, replace the capacitor and test it again. Maybe, but we already know that works. And I'd have to replace it with a 100 volt one. I have those, but... You know. Okay. Okay. So, this is minus. If I follow the trace. And this is plus, right? Okay, I need to connect these wires again. Hold on. Let's enable the output. We're at 5-ish volt, 10 milliamps, okay? And I said this is plus, this is minus, okay? I'll try and do it in a way it doesn't block the camera. So, minus, plus. Okay, nothing's happening. I need to make sure my connection is working. Hold on. Think I need an exorcist right now. Just make sure we have an output. Yeah, we have 5 volt coming out, so that's not a problem. Yeah, we only have one chance, so we need to raise the voltage slowly, or the symbols could be wrong. Could be that the LED is on in reverse, because as I mentioned, the minus trace is coming out of the inductor, which doesn't make sense to me, because there's a P-channel MOSFET in front of it. So I'm going to try and reverse it. Okay, should I try and reverse the wires, cross the streams? Because I think plus and minus is reversed. Then it says on the PCB. Anyone against that? Yes. Okay, let's do it. So this is now plus, and this is minus. Nothing happens. But it was constant current limit. Let's see if it constant current limits like this. So like this, nothing happens. And an LED is a diode, so that would make sense. And like this, we see CC. Hey, wait. We don't? Yeah, we do. Right? CC. But the voltage gets drawn down. What happens if I short circuit it? Same thing. But no voltage. Where to go from here? Higher voltage? Because we're at 5 volts and this thing is officially 6 volts. I'm thinking higher voltage, but I'll wait for your reply. 6 volts. Okay. More current, more smoke. Yeah. Let's go more voltage first. Okay. We're still constant current limited. I'm going back to 5 volt. And we'll do 50 milliamp. Okay. Oh, I saw it. Blip. You seeing it blip? Okay. Let's go to 150 milliamp. It's still constant current limiting. Okay, I'll try it in reverse again, just to be sure, but I don't think it'll draw any current because it's diodes. So in reverse, nothing happens, which would make sense, they're diodes. Voltage drop, no, I think that actually means it wants more current. So let's go for broke. Let's go for 500 milliamp. Okay. Still constant current limited. Okay, let's go for 6 volts. Oh, it blipped again. Yeah, it's blipping. I'm thinking more voltage. What do you guys think? Go to 10 volts? Or 9 volts? Should we go to 9 volts immediately? Because it makes more sense that it's 9 volts. Three amps. What? Current lower. Okay, yeah, the polarity is correct, otherwise it wouldn't blip. Okay, we'll go to 100 milliamps, 9 volts. Yeah, we'll work our way there, Scott. So we know this is the correct polarity, otherwise it wouldn't blip. Okay, it's still blipping. Not anymore. Wait. No more blippage? Okay, still blips. Okay. I'm going 500 milliamps. See what happens. Still blipping. 9 volt was too much? No, I think it's still too little. No, we're directly connected to the diode, Emil. I think that the other stuff doesn't matter. Okay, I'm going back to 100 milliamp. I think it still needs to be more voltage. I think, Yeah, more voltage doesn't make sense, huh? Let's go to 1 amp. Okay, let's go to 6 volts, 1 amp. Just to be sure. 6 volts, 1 amp. It's a heavier blip. So it's just drawing 1 amp. Okay, let's go to, oh, no, 2 amps. I don't know. 3 amps? Well, that's brighter for sure. But now voltage is likely too low. So let's go to back to 1 amp. I'm going for broke. 10 volts. No, nothing's getting hot. Well, it has to be a buck converter and not a boost converter. A buck converter, not a boost converter. Because otherwise the voltages wouldn't make sense. And it can't be a SEPIC converter, because then it needed 2 inductors. Interesting. CSO says no. Keep. Okay. Yeah, but it's constant current limiting. And you think that's because the voltage is too low? No. Okay, let's lower the current. And I'll try and hold this in place. Okay. Okay, more voltage. Doesn't do anything if I up the voltage. We're now at 19 volts and it's only consuming 0.59. So I'm going back to 6 volts and I'm going to current. Yeah, that doesn't make sense either. We're now pumping 5 amps to it. So it's likely that something... Oh. Nothing's warm, so likely something is indeed influencing the circuit somehow. But I wonder what it is. Okay, that's the last thing we're doing, because I'm getting tired. Hold on. Oh, we've only been going 1.5 hours? Wow, okay. Okay, I set my iron to, or my hot air to 420. See, normally I'd get this tired after 4-hour live stream, not 1.5 hours. It feels like 4 hours. Okay. So let's wait a little. Well, we need to heat up the PCB anyway. I set it to 420 degrees. Let's give it a bit more airspeed. Oh wait, no. No, I'm not desoldering the LED. That's gonna destroy it. I'm desoldering the diode and the inductor, because that would effectively break the circuit. Hey there, Dave. Oh. $1,000 degrees. Yeah, that's gonna take a little bit. Well, it's one of the botched IKEA ones, so I don't really care. Okay, that's one diode. Oh, I guess when we're busy, we can do the rest too. Oh, we're almost at that. Wow, you MOSFET. Okay, well that should be plenty. I guess I'll flap it in the breeze a little bit. The smell of hot cork fills the air. This is how you get spare parts. Well, these spare parts are slightly cooked, so I'm not sure this is the way, but you know. Not really. MOSFET looks okay. Oh wait, you can't see. Ah, MOSFET looks okay, but the inductor certainly has some weird. I guess it's not rust if I can do this. Probably. I guess it's flux then, but rosin flux. Come on. Okay, whatever. The MOSFET is a... 1 second. It's a fairly common one. It's a SW, some Chinese brand, P30 NF06. But the 30 NF06 is a very popular one. Or a common one. No, well, it didn't catch fire, so that's okay. I guess we should check what temperature the PCB is before turning it on to give it some fighting chance. Let's see. The inductor is still 90 degrees, but the PCB is like 48-ish. Something like that. I can't really show you. Okay. Doesn't matter. That's fine. We had it like this before. So, what are we doing? 6 volts. Let's go for, I don't know, 100 milliamps. I guess we need to start over now, huh? 6 volt, 100 milliamps. Oh wait, no, it was the other way around, I think. Was it? No. Well, at least now nothing is happening. Did I kill it? Possibly. If I short circuit it? Yeah, that works. So nothing happens like this. Okay. And nothing happens like this. Well, I didn't heat up the LED. It's not drawing current because it might need a higher voltage. Let's go to 9 volt. Nope. Nope. Get a new fire stop. Thanks there, Scott. It's not doing anything. Oh, there we go. Oh, yeah. We got it. So it's drawing 7.82 volts of 9 at 100 milliamps. And interestingly enough, the plus line goes to the diode and not the inductor. Who would have thought? Light at the end of the tunnel. Exactly there, Bella. So this is 0.7 watts. But because it's not consuming the voltage, we can up the amperage until it does. I'm going to try and keep this on here while I'm blind. I think it's on, yeah. Okay, this is at 500 milliamp. It's drawing 4 watts. Let's keep going. 1 amp. It's drawing 8 watts. It's certainly getting warm. 1.5 amps. 2 amps. It's getting blisteringly hot. And we're now drawing, well, close to the 9 volt. Wow, that's a lot of light. Ow. Yeah, so it's likely, well, we could lower the voltage, I guess. Okay, as we thought, 6 volts, definitely not enough. 7 volts, slight, oh god. Let me see if I can do it this, well, don't do that. Okay, I'll try and hold it. No, still can't see. Okay. There. 6 or 7 volt. We barely see it lit. Come on. There. Let's go to 8. Oh, wait. 8 and 9. And now it's drawing the 2 amp we've set. So let's see how much it'll draw. 3 amp. Okay, if we set it to 3 amp, it's only drawing 2 amp. So we're at 18 watts. So let's go back to 2 amp. And let's give it 9.5 volt. And then slowly up the amperage again. And then it'll start taking more. Because in theory, it's a 30 watt diode. Or LED array. Yeah, so with 9.5 volts and 3.3 amps, we're at 30 watt. And my fingers are burning. Ow. Oh, some electrical tape. I could try that. That's a good idea. I'll use some Kapton tape. Because that can take the heat. Now blow it. Don't worry, we will. We will blow it before the end of the stream, that's for sure. Okay. Scissors. Okay, power supply is off. We limit to 1 amp. Just to make sure I have the polarity correct this time again. I believe it was like this. It was. Ow. Jesus. Okay, now I have to somehow hold these in place and put the tape on. Ow, that's hot. Ow. Ow, ow. Thanks for being here, Earth Gamer XE. Have a good night. Which is an N-channel MOSFET. That's interesting. That could explain why I don't understand the circuit. Sorry. Right, let's see if this bodge work here did it. It did not. Ow. Okay, let's turn the amperage down. There. Non-blinding, please. Oh, it's still blinding. Okay. Ah, these glasses start to hurt. Still blinding, Jesus. Can't see the display anymore. That's better. Ah, man. Now it's, you know, I have all kinds of spots in my eyes. Yeah, let me figure out the best way to do this. I'll be right back. I think I've got it. Some vice grips. Wait. Oh man, I'm still seeing spots. Okay, let's see. I think I said it correctly. There. No, there we did it. That did it. Yep. Can move it around. Nice. Okay. I'm gonna angle it the other way because it's going to make me blind. I guess I should put some airflow on it, huh? I'm gonna angle it like this actually. Then you guys can go blind and I don't. Okay. Let's up the voltage to what are we gonna do? 9.25? What do we want to do in regards to voltage? We're not going to blow it up first. We're going to blow it up after that. Upside down? I know airflow might be a good idea, but it's allowed to die. That's fine. We just want to see how much it can draw. 9.9 volt. No airflow. Desoldered by himself. We're going to go 9.25, and then we're going to slowly raise the amperage, right? I know. I don't have a casing and heatsink. It'll die. It's fine. So this goes very linearly. Okay, we're back at 20 watt. That's basically what we saw using the included driver too. Let's go further. We're not constant current limited anymore, so now I can raise the current as much as I want. Nothing happens, because now the voltage is limiting. See that? CC and CV. Check the temperature. It's a metal surface, so that's a bit tough. But it's pretty bright. Wait, I guess I could. There, now we can actually see what happens while we can't see it in real life. I mean, you can still see it's bright. So, let's set it to 4 amps, which is nuts. And let's start upping the voltage. Uh-oh. It's not taking more voltage? Oh, it is. Oh, what? How is it doing that? When I up the voltage, the amperage lowers. Sometimes. But the wattage isn't changing. See that? We're now at 10 volts. And it's actually less bright. Is it dying? Yeah, it's dying. Yeah. I think so. Okay, let's go to 10 volts, 4 amps. It's flickering. Doesn't like that. Well, it's still pretty bright. Yeah, but it's just a diode. It can't really limit by itself, can it? Oh, yeah, it's... See that? See the amperage? Slowly going down. Okay, let's try and see if I can measure how hot it is. Oh, it's smoking. It's 170 degrees plus. It's smoking. Let me try and show you real quick. Yeah, it's smoking. It's, let's see, 170 degrees. Well, it's more than 170 degrees. My measurement device cannot go over 170. I don't want to blow out the sensor, so... Yeah, there's small puffs of smoke. See that? See the smoke? Oh, it's starting to flicker. No, you can see the smoke. I see the smoke. Hold on, where is my mouse? Like that, I guess. I think it's slowly dying. Yeah, I can't give it more because it's not doing... Oh, I guess I could give it more voltage. More voltage! Oh, now it's smoking. We're now at 11.4 volts. Amazingly, the wattage isn't going up. It's dying now, so it's going down. Let's go to 12 volt. Yeah, it's not doing too great. Oh, it's slowly dying. It's dying. Aww. Okay, more volts. 13 volt. Yeah, no, it's almost dead now. It's flickering and it's not that bright anymore. There's smoke coming off. Oh, it's only drawing 0.2 watt. What happens if we back off voltage? Let's go back to 9 volt. Turn it off. Still looks intact, but that doesn't mean anything. No, don't worry. Oh, Philip, finally we get smoke on stream. on Steam. What? Die LED die. Okay. Let's wave it around a little bit. Okay, let's see what it does. Nope, 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 it's very dead. This LED is goner. Oh wow. Okay, let me try and show you. If you look closely, the middle row has died. See that? So it's now 2 rows of 3. What can we do to kill it? More voltage. Let's go. Whoop! There we go. 20 volt. It's alive again. Oh no, it's smoking. Let's go. 24 volt. 25 volt. We resuscitated it with, oh, no, it's not, it doesn't want to live. More voltage, little guy. Oh, now it's dead. Okay, 30 volts, 31 volts was too much. The little guy didn't survive. I was trying to bring it back to life with high voltage. It didn't work. Okay, let's turn the power off. Oh, poor little guy. It's all black and weird colored inside. Yeah, that looks like it didn't survive. Huh. 100 volt. No, I don't think... The max I can give it is about 60 volt. We'll try, we'll do that. Okay. Oh, what? It's drawing 4 amps? What? How? Where is it going? Okay, more volts. No, it's only drawing 1.4. No, more volts doesn't matter. Well, we can give it more amps. Let's give it more amps. We got 24 amps here. Let's go! 10 amps! Oh, it's raising voltage. Okay, 15 amps. Nothing is happening. Oh, no it did. Did you see that explosion? 20 amps. We're at 70, 73, 74, 76. Oh, there we go. No. It was almost back to life, and then it started to stink a lot. Okay, let's go. Let's try it one more time. Let's kill the power. Let's set it to 20 amps at 20 volt. And this is our last attempt to resuscitate LED Boy. Let's go. Oh! Did you see that? What was that? It blew up. Okay, one more time. LED Boy, live! Oh, no, fire! There's fire. Okay, that's enough. I think LED Boy's dead. Okay, he tried very hard. LED Boy is no more. Nope. Oh no! Oh no! Yeah, he's dead. LED Boy is dead. Can we have 1 second of silence for LED Boy? That was it. Okay. Yep. Man, I just had COVID. Why am I making smoke? No, we didn't need the fire stop. We have to desolder it? Well, it obliterated itself. I mean, there's no desoldering needed. Right? Exactly, this is the best stream ever. Magic smoke, sparks and fire. More donations from Philip. He just keeps pouring it on. This deserves more donations. Thanks, Philip. Well, actually, Philip has now paid for the light. Will you be going photon induction way now? What? What's underneath the LED package? Well, solar pads. Just two, plus and minus. Yep, that's it. I'm calling it. It's dead. It's gone. It's not coming back to life. My vices are slightly burnt. That's okay. That's what they're for. I'm glad I wasn't holding the wires. Okay. Whew. Can I remove my glasses now? Let's turn off all the power. No more power. Okay. Oh, man. Such excitement. Time to sleep, 5 a.m. here. Well, are you glad you stayed there, Dutchmaker? You've blown up LEDs before. I know you have, so... Sneak peek time. Oh, that's right. Yeah, we can do that real quick. I have to clean up a little bit. Let me put these over here. I need these wires. How hot is this? I don't know. There, I've got the wires. I'll check it out, Emil.
Very much alike.
There. Cleaned up. This LED deserves to be in a showroom on Discord. Well, you'll have to cut the footage and put it there. So, of course, I do a lot of things with LEDs, as you all know. And I always like to look for new stuff. New stuff. So I've been working with a company, and this isn't fully on the market yet, to make a kind of custom LED strip, I guess you could call it. It's not that custom, as in that it's a specialty product or something like that, but it's also not available on AliExpress or Alibaba or something like that yet. Hold on just a second. And it has to do with the analog boards we're soon going to be releasing, I hope. Still working on that. But it's going well, so that's good. And one of the things I wanted my new boards to do was be fully 48 volt compatible. And as you can see today, they certainly are, because we did all kinds of weird crap. And my little dimmer board here didn't give a crap. It just worked. So that's good. Let me think. Where is it? I need to take off the wire thingies here. So what we have is a new type of strip that is a combination of a few things I like. It's a cob LED strip, but not like you're used to. It's fully weather tight. And it's 48 volt. So let's take a quick look at that. And I'm thinking of maybe starting to sell this myself, because it's not something they produce or sell normally. So So let's go back here. That's a bit close. Whoa! There. So normally when you have cob LED strip, let me get some analog cob LED strip. Good. Oh, I have some here. So normally when you have cob LED strip, it kind of looks like this. You have the LED strip and you have the cob material in the middle under which the flip chips or the LED diodes are. And you can see that on the back if you take, well, let's just move it all together. If you, no, okay, hold on. I generally don't like this stupid blue tape, it's too thin. Sticks okay, but it's just a bitch to get it off. Oh, okay, I can't show you here. Anyway, you have the cob material in the middle, but then you have all these exposed pads and things like that, so you can't use that outside. And although it's well diffused, it's not perfectly diffused, and it's a very small area that's generating the light, right? So what I've been trying to get is this stuff. So this is a single color CRI 90 cob LED strip, but it's fully weather sealed. And it got a bit dirty just now, okay. And it's in a diffused cob layer on top of the cob strip itself. So it's fully IP67, I believe, officially. So you can use it outside, but the biggest advantage is that it doesn't have the small sliver of cob material anymore. It has a frosted layer that's much bigger. So if we hook this up to my little dimmer here, let's see, positive. And negative. Let's use channel 4 again. It's not heat sinked, but partially because it's 48 volt, it doesn't really need to be, because it doesn't really get hot. It's only 10 watts per meter, so it's not crazy bright. I have to make sure these leads don't touch. Anyway, let's turn on the power again. No, turn it fully off. Okay. There we go, let's boot. VSET 48 volt. No, we already know the A and Mini is 48 volt compatible. Let's set this to 5 and have to wait for it to boot and go into Wi-Fi a little bit. So funny that the controller draws so little power that it just doesn't show up. Come on, little controller, you can do it. There we go. Okay. So let's set it to 10% so we can take a look. So even at 10%, and you can't see it because the studio lights are on, it still lights up. Let me turn off the these lights. There. So even at 10%, it still lights up. But even on camera, you can't see any hotspot whatsoever. It's perfectly diffused. And that's at the lowest setting it'll go. And that's very low because you can see on my face, which you can't see. Let's go to 50%. There, now you can see my face again, and you see this is now much brighter. And still, 0 hotspots because of the basically double diffusion, but you don't need an aluminium profile or a diffuser on top of that. And this one also blocks very little light instead of a lot of light. Did it show up if you put it on 5 volt? No, it's 48 volt. I'm confused. So, yeah, let's put it on 100%. You can also see the power it draws. And this is 5 meter of the stuff. So it's drawing 44 watts instead of the 50 it could potentially draw. I haven't checked yet if you double inject it. I guess I could check that right now. If it would draw the full 50. Let me make sure I don't cross these wires here. No, even if I do front plus back, it only draws 47.5. And without that, it draws 44.6. So that also gives you an indication that there's very little voltage drop. Because adding an injection at the back basically does nothing. And, well, this is 100%. And, well, you can see it lights me up pretty decently. Actually lights up the room pretty decently. It's not the brightest out there, but it's pretty good. And it's cob LED, so it's pretty efficient. It's about 110 lumens per watt. While still being CRI 90. Still have to verify that. But from what I see, the colors are pretty good. It's 2700K, so it's nice and warm. And yeah, that's basically what I've been working on to get for my new boards, because those fully support 48 volt. At 43 voltage also will work. I don't know. Yeah, sure it works, but it's a lot less bright. Now it's only drawing 11 watts. So I'll try 1 volt higher. Well, didn't explode at 49 volt. Let's not do that. Okay. But yeah, this of course works perfectly in regards to dimming and things like that. But it's especially different because of the 48 volt configuration. That's not that common yet. And the special material around it, because of which you really don't need any diffusing layer on top anymore. Which is, well, you know, a lot easier and very nice. Cut points are still there. You can't actually see them if the strip is on, but if the strip is off, let me turn on my studio lights again. You can see there's a cut point here, cut point here, cut point here, cut point here. You can basically see the copper kind of coming through the diffusion layer. And, well, those are the points you can still cut them. Here, probably they solder two together because it's slightly less pretty. Let me take a look at the back. So, on the back, let me turn it on just a little bit. On the back, it looks like this. So, you have the cob LEDs in the middle, basically, and there's a silicone sleeve. Well, clamped in there. You can see them lit up. Those are all the LEDs. And yeah, it basically behaves like normal strip. It's just 48 volt. And nicely weather sealed, and it has a very broad pattern of its own, so you don't need additional diffusers and things like that. Yeah, it's about every 10 centimeter. I haven't checked that actually. Okay. Let me check. Yep, every 10 centimeter. I can't really show you, but yeah. It's not the most special thing in the world. The technology exists. We have the technology. But I don't know if they use resistors. I haven't pried it open yet. But it's not... It is the newest technology in that regard, that it's cob and stuff like that. But it's the combination of 48 volt and the weatherproofing and the diffuser on top of there, which I like, because that combines a lot of things we often struggle with. And now you can easily do a 10 meter stretch because it's 48 volt. It doesn't really matter. Sure, it'll dim a little bit, maybe, but you have to worry about it a lot less than already, again, with 24 volt, for instance. Sure, Timothy, but that's a bit little to go on. What do you define as good? Sure, yeah, these could be used for under cabinet lights in the kitchen. And because it's 48 volt, you basically never have to worry about injections until you go past 10 meters or something like that. Even if you're running full brightness. Could you blow up just a small piece of the strip? You mean with extra voltage? Maybe at some point, not right now. I only have a few samples, so... But yeah, I'm thinking of selling this in the AllNet store together with the new controllers once those are released. Because then people could easily build 48 volt compatible projects with the dimmer board that's 48 volt, a 48 volt Meanwell power supply, and these strips, and they'll know they'll have a perfectly working setup and strips that are verified by me, etc., etc. Yes, these are perfect for under cabinet moisture, in the bathroom, outside, things like that. You shouldn't submerge them, but anything else should be fine. Yeah, but the problem is, if I cut 10 centimeter right now, these plugs are specially, well, sealed, basically. Although I think it's just heat shrink with glue inside, which I could do myself, but... Oh, sure, I can do that. I can do that while it's running. That's fine. I guess I'll disconnect the LED strip real quick. That shouldn't matter with analog, but you know. We're using between 0.10 and 0.15 watt. Well, there is no model code or code for this strip because it's a custom product right now. So yeah, this controller it draws almost nothing. Yeah, so anyway, that is the secret for today. That's something I've been working on, just like the boards, but I've shown the boards before, but we're getting closer to doing pre-production prototypes, and once that is done and the final changes have been made, we'll do actual production. I don't know the cost yet, Emil. It very much depends on the amount you order and things like that. It won't be hella expensive, but it won't be the cheapest on AliExpress either. Those are crap strips anyway, so yeah, I don't want to sell crap. So yeah, that was fun. We had fire. We haven't had fire in a long time. Have we ever had fire? I don't remember. So Quindo is back with fire. With a blaze. I don't know. Something like that. How did you get the strip? I asked a manufacturer in China to make it to my specifications. Yeah, CRI 95 is possible, but for general applications, CRI 90 is often plenty, and this is a decent. This should be a decent CRI 90, so not a bodged one. But I still have to verify that. And yeah, CCT, sure, but CCT has its downside in less illumination, more spots because the LEDs are further apart. Things like that. So you need to start somewhere, and for generic lighting, things like CRI 95 isn't really needed, although I'm a big advocate of it, and CCT isn't needed. Yeah, so have to start somewhere, and then if it takes off, we'll expand from there. Don't try to do everything at the same time when you're trying to sell stuff, because then basically you never sell anything, because you're always working on getting it released, and it never gets there. That's been my experience, at least. Oh, nice! Well, that's going to be a much better one than I have, probably, there, Dutch Maker. Knowing what you're working on, so... Yeah, but I'm really liking the Mini so far. We've already used it in several tests, and it's performed beautifully. I mean, we killed a few lights today, didn't care. So that's good. One of the reasons these boards are using this little power, it's still on by the way, is that I'm not using an LDO on there. No, wait, on this one I am using an LDO. Sorry, it's a different version I'm not using an LDO on. Doesn't really matter. Right, so I'm gonna sign off because I'm done. But I do thank all of you for being here. I had a blast. You guys had a blast, I think. And yeah, I hope to see you back next week. We'll probably have a Quinled video, when I've been wanting to release for a few weeks now, but I'm finally getting to. And you guys have a good night. Bye-bye.